Hello everyone, my name is David Khourshid. I work at Microsoft, and this is my toothbrush. And there's a reason that I'm showing you my toothbrush. I know it's really random, but everybody is different. Everyone has different abilities, different personalities, different uses, and these types of behaviors, just like Luca was talking about human behavior, these change over time, all right? I mean, everyone here is different. You're all pretty white, but that's okay. But the point is that when we think about how we develop software and user interfaces, we need to consider everyone, no matter where they come from, and that's why ability and accessibility and internationalization is so important. And so the way we develop user interfaces in software right now is sort of like a toothbrush where we all share the same toothbrush, and that's not good because nobody wants to share the same toothbrush. We all like our own toothbrush, and in the same way, we all like our own user interfaces. So let's talk about the current state of the world when it comes to how we could affect change with regard to user interfaces in software. One common technique is A/B testing, but that effectively splits the population of our users into two groups: those who, those who stick with the same software and those who might like the new version of whatever app we're working on. But the problem is that we don't consult those users when we're developing this. And so the way that we usually develop software is in closed meetings and just by a handful of stakeholders that don't represent the population at large. And so this is why things like A/B tests are ineffective, because essentially, at worst case scenario, you're going to piss off half the people and make half the people be like, okay, this is sort of cool. But whenever you change something, you are trying to enforce that same change on absolutely everyone. So also, there's something called funnel charts. And so if you've worked with things like Kissmetrics, Segment IO, Mixed Panel, you'll understand that there's these funnel charts where you see how user conversion happens from step to step and how users either continue through all the steps in the user interface or they fall off at certain steps. And the problem with that thinking is that user flows are not linear. Users could do different things. Users can explore the app in different ways. And so it doesn't make sense to track the metrics of just one simple flow through the app. And instead, you have to thread through all the possible ways that a user could use your application. So one of the recent projects that came out, I believe last year, it was highlighted at Chrome Dev Summit, I believe, or Google I/O, whatever it's called, is Guest.js. And so Guest.js is based on predictive analytics inside the browser, working with your Webpack apps to smartly chunk your bundles in a way that basically when a user visits a page, then it uses Google Analytics or whatever other metrics to determine what is the best next page to prefetch. And if you don't know what prefetching is, that means that the browser silently starts loading it in the background so that when the user ultimately visits that page, it becomes instantly loaded. And so that's sort of the idea behind Google AMP project too. I talk about Google a lot. I work at Microsoft, so sorry Microsoft if you're watching. But so this is based on predictive analytics, where not only do we measure how often users go from one page to the next page, but we also look at a whole bunch of different properties on the user, like which users are more predisposed to go from this page to page A, or to page B, or to page C. Using those analytics, we prefetch, and then we load the page. So this is a pretty interesting project, and it definitely plays a role into just the overall picture of making better user interfaces and reading the mind of the user in a way. And so this idea is called adaptive user interfaces. One misconception is that when we think of adaptive user interfaces, we think of adaptive design or layouts. And adaptive design and layout is related to how we could modify the app based on the viewport or based on the device, where it should act and behave differently, whether it's on an Apple Watch or a phone or a computer or a big projector. But this is not exactly what we want to think of when we think of adaptive user interfaces. Instead, we want to create software that adapts to the behavior of people, whether it's individual or groups, and not just devices. And so, to give you an example of an adaptive UI, probably the most famous example is this little guy right here. Y'all remember Clippy. And Clippy was one of the first adaptive user interfaces. In fact, early versions of Microsoft Word had many of these instances of adaptive user interfaces, especially with the toolbar showing and hiding certain items depending on which ones the users were using the most. Now, Clippy used predictive analytics and sort of machine learning at the time to determine what the user was doing and make suggestions based on that. So it's an assistive UI and it's also an adaptive UI as well. So here's another example of how we could use adaptive UIs in changing the way that we develop like common user interface patterns. So I'm sure you've seen this pattern before. When you delete something in an application, you could click yes, you could click no, because it confirms, like, do you really want to delete that? But adaptive UI is different. Adaptive UI would take a screen like this, measure the analytics of the user, and say, how often do they click yes? And so we could say that that most of the users are probably going to click yes because it's a big red delete button and you don't usually accidentally click it. Of course, there are those users who sometimes accidentally click it and they're like, nope, I didn't want to do that. So that's why a better user interface would be one where we predict that the user is going to choose the most common action, which is delete it. And of course, we give them a chance to undo it, which is this nice faded button over there. And after a second or two, we just delete it. So in this deleted phase, we're sort of not deleting the file yet, or not deleting whatever they want to delete, but instead we're giving the user an option to undo their choice. So one of the more recent adaptive UIs I've seen and predictive UIs is not Google Inbox, I'm sorry, too soon, rest in peace, Gmail. And so Gmail, I don't know if you've tried this, but it's really cool. It predicts what you're going to type based on the context of what you're typing. And it does this because Google has so much data on all of the emails sent. Well, I guess that means they're reading our emails. I don't know. Anyway, so it will predict the next thing that you're about to type, and usually it's correct. It's been scary accurate in me typing emails. It takes me super fast, and I'm guilty of being that person who, when I get an email in Google Inbox, or sorry, Gmail, I will press one of the predictive choices there because I'm like, number one, I'm too lazy to type it out on my phone. Number two, it's easier to just, send one of those default choices. However, developing adaptive user interfaces is definitely challenging. And so there's a lot of things involved with adaptive user interfaces, such as the intersection between human-computer interaction, artificial intelligence, and also user modeling. And you could see all of these things sort of combined here. It definitely is a lot more than taking a mock-up, putting it in React or Vue or whatever, and just implementing it. So how could we do this with our current development? So we have to shift our mindset and think about model-driven development. This is something I've been talking about for a couple years now, and something that I definitely talked about last year. If you were here at React Finland, I gave a talk about state machines and state charts, and how they could really help us model our user interfaces in a very declarative way to prevent bugs and to visualize and all of these other benefits. But we're going to see that model-driven development really has a lot more benefits than just helping us developers. So when you think of a model, think of something like a user flow that a designer might provide you. But these schematics, these specifications for how your application should work, are essentially a way that we could develop apps And well, I'll just show you. So finite state machines, this is something I talked about last year, but in case you need a review, basically what I was trying to say is that we could develop our apps so that they are these finite state machines. And so you could imagine an app where you sign in, that would be an initial state, and then we would have our finite number of possible states, such as signing in, going to the home, or going to the profile. We have a finite number of events as well, such as being able to submit the sign-in, and then whether it's a success or you're unauthorized, it takes you to a different state. And then from the home screen, you could go to the profile screen. So just like the user flow over here, we could create state machines that describe our app in sort of the same way and actually make them executable. And this is something I was talking about last year. So yesterday at my workshop, there were about 20, 25 of you at the workshop. We created this screen right here. This is a very simple flow where you could think of it as a feedback app, like little components that sort of pops up and says, how was your experience? The user could answer good or bad. If the user answers good, it says thank you. If the user answers bad, it goes to a form where it tries to gather more information from the user, and then it's submitted. Now, if we think about our goals here, our goal is to collect information from the user to better provide a user experience. And so don't think of this as just a mock-up, but think of this as a goal to accomplish with our software. So if you're not familiar with XState, XState is a way of creating finite state machines and state charts that could model the user application and the user interface and all of the requirements involved. And so it's essentially just an object, just a JSON object, where we look up the state. In this case, let's say we're on the question state. We look up the event that just happened, such as click good, and then we navigate to that screen. Now, something fairly recent that I basically just released a couple weeks ago is XState React. And XState React provides a use machine hook where it's one line of code. So you take this use machine hook, you take your machine, you put it in use machine, and just like the use reducer hook, you have the current state and you have a send. I like using send instead of dispatch because it's less to type. And there you go. This is all you need to manage your state, so take that, Redux. And so I talked about many of the benefits of using state machines and state charts in the past, such as determinism. We could know exactly which state will follow given a current state and an event, but we could also take that abstract model of our user application and we could visualize it. And we could also communicate between developers, designers, stakeholders, and more with those visualizations. But those are all very developer-centric. And so the more benefits we see, the more we see that we could actually get to benefiting the user experience, such as testability, making sure that we test all possible edge cases, simulation in actually executing those edge cases and seeing how it actually works in the live system, and even analytics, which we're going to be talking about. So here's the game plan. In order to make adaptive user interfaces, we first need an abstract model of our system. Now, state charts and state machines are the popular way of doing this. I've also seen people using Petri nets. That's fine. It doesn't really have a strict standard, but yeah, it's just another thing that you could consider. So then we capture transition analytics, and so that means what happens and when it happens, and where it happens as well. And so these transition analytics include things like user information, the state that the user is in, and the events that occurred, and what time it occurred. So then we also take our abstract model, which again is modeled as a state machine, and we see which parts of it can become adaptive and change. And then we use the analysis that we collected in step 2 for that adaptation. So the first concept to understand when it comes to all this is weighted graphs. So let's say that we have our part of a state machine, and we have a signing in state, and two things can happen, either a success or an error. So we could collect analytics on these two transitions, whether it goes from signing in to success or signing into error, and determine the rate of each one of these. And so these are called edge weights. And so this makes a weighted graph. And some of you might know this from university, so bringing back those memories for you. Now, these weighted graphs can also be visualized as well, and we could see which paths are more likely to happen based on these analytics. And so I did this about a year and a half ago at Microsoft using, when I worked on the Visual Studio Live Share team, I used a state machine to both model the user interface of how users logged in and out, and also collect analytics. And so using D3, I was able to visualize this chart and see the flow of people, how many people shared the session, how many people joined the session, and what was the error rates as well. So let's take a look back at our feedback app. And let's decide that one of our business goals is that we do want to capture information from the user. So we want to capture whether they clicked good or bad. We want them to tell us why. And so one way we could do this, of course, we could take them to the thanks screen, which they're likely to close it. But we also have a give feedback button where they could actually go and give us feedback. And of course, clicking bad makes them give us feedback anyway. So by measuring the analytics of the transitions and determining which path the users are more likely to take, we could actually adapt this UI, and I'll just show you. And we could make it so that it adapts to the user. So in this case, I'm not using any analytics platform. I'm just using local storage. So it's a very local solution. And so how it works is, let's say as a user, I click good. My experience was good. And then I see this form. I'm like, I don't want to fill out a form. It's like, I had a good experience. Don't ruin it for me. So I press escape, and I get out of there. So the next time this shows up, I click good again. Of course, it shows me again. I'm like, I'm getting really tired of this. I press escape, reload. Then I press good. OK, it's asking me again. So now, after a while, the system adapts, and it says, thanks for your feedback. And this is what we want because it adapted to the behavior of the individual user in that it gives me the thanks screen, but it also gives me an option to provide feedback. And so now, every time I go on here, it will do the same thing. But if I decide to provide feedback, and I'm like, you know what? My experience is so good, I actually want to tell you about it, then the application will adapt, and it will give me back my screen. And of course, if I go and exit again, then eventually it will go back to that screen. So that's just an example of an adaptive user interface. All right, going back here. Cool. That should be adaptive. So the tricky part about adaptive user interfaces is that it sort of gets into the realm of probabilistic or non-deterministic state machines because we could have two possible transitions, and those two transitions happening on the same event need to be based on something because, remember, one of the rules of state machines is that you can't be in more than one state at the same time. And so that's where analytics come into play there. So there's two ways that we could do this analysis. Like once we have our abstract model of the system, we could first determine the analytics of how often these paths are taken, either by the individual user or a group of users or certain demographics of users. So for example, we see over here, let's say that we're making some sort of Instagram application. We log in, and it takes us to the gallery by default. And then from the gallery, the user is either the user could either scroll through the gallery, or they could go to the camera, or they could go to the profile. So we measure those transitions, and we see that going from login and staying in the gallery, we have a 90% chance of the user going to the gallery, and then a 31% chance of the user staying in the gallery. Now, a user going from login to gallery to camera, we have a higher chance because we see that users have a tendency to go directly to the camera. And then over here, login gallery profile, we see users are less likely to go to the profile. So what we could determine here, and the way we could adapt our UI to fit the user's needs, is we could see that since the user is more likely to go from the login screen to the gallery and then immediately to the camera, we could identify that desire path, which is what it's typically called, and go directly from login to camera as part of an adaptive user interface. And so just like the feedback app you saw, we could do all that. We could also analyze actions as well. For example, trying to decide when ads are supposed to be displayed, we could score those actions, and depending on certain factors, we could see whether ads should be interspersed or on top. Sorry, I'll show you that over there. And so, we could measure these based on what's known as decision trees. And so these decision trees are just data from the user where we determine things based on that data. And so this is very important in reinforcement learning and machine learning as well, because we take a lot of data and then we determine, based on certain factors, what should happen based on the data that we have. And so it's a very statistical model of deciding what to do, based on the user. So using state machines, we could do graph analysis on these, since these are directed graphs, and they do fit that model. So we could use shortest path algorithms to determine where users are going to go, and we could also use analytics to track. This is XState again, where transition statistics. So for example, we could give it the target, the source, event, and timestamp, and we could determine, based on how many users go from one state to the other, the likelihood that they will travel from, for example, A to C. And so we could see here that the shortest path is not ABC, but instead it goes through ADEC. And so that's the intuition that we have to keep in mind, is that the path weights matter. And so there's a whole bunch of other ideas that come along with this, including higher order markup models, where we could get more accurate predictions if we don't just determine what the user might do, but what the user previously did as well. And so you could see that the prediction changes based on that. So reinforcement learning can also be used where an agent, whether that's a bot or just something we program, can interact with an environment and get rewarded based on accurately predicting what the user did or did not do. And so our overall goal is to make applications that have this adaptive user interface, have an executable abstract model of that system, track metrics in just, 4 lines of code, feed those metrics into your analytics platform of choice, and determine which transitions can be made adaptive. And that way we could have these adaptive UIs. And so there's many benefits to adaptive user interfaces, and I'm running out of time, so I'm just going to list them here. You could talk to me if you want to know them. But there's also a lot of modeling considerations, such as whether you should fit this to a user or fit this to a group of people. And so in XState, I've been working a lot on these sort of ideas because it's not just a state management library. It's a lot more than that. It makes these abstract models for your applications. And I just released XState React and XState Graph, which gives you those shortest paths and simple path algorithms. And there's a lot more coming down the pike, such as XState View, a visualizer, analytics, simulation, and testing utilities as well. So I'm going to leave you with saying that our goal should be to make your code do more than it's already doing, and to also improve the developer experience and the user experience. So thank you very much, React Finland.